Hi everyone, my name is Neha and this is the sixth lecture on Introduction to Automation. In this lecture, we are going to learn about proximity sensor. Proximity sensor is a sensor able to detect the presence of nearby objects with or without any physical contact. So these proximity sensors, they often emits an electromagnetic field or a beam of electromagnetic radiation, for example, infrared, and then they look for changes in the field, and based on that, they return the signal or they respond. In proximity sensors, the object being sensed is often referred to as a proximity sensor's target. And there are different proximity sensor targets which demand to use different sensors. For example, a capacitive proximity sensor or photoelectric sensor, and this might be suitable for a plastic target. And then we have inductive proximity sensor, which always require a metal target. And then these proximity sensors, they can be used for the mobile applications. For example, during a telephone call, proximity sensors, they play a role in detecting accidental touch screen taps. And when mobiles are held near the face during a call, then it turns off the display to prevent any keypad presses, and it also helps in battery consumption from the display. Now there are different types of proximity sensors which we are going to see. First is the limit switch proximity sensor. Second is the optical proximity sensor, and the third is Hall effect proximity sensor. So let's first start with the limit switch proximity sensor. So these limit switches, they are one of the most common presence sensing device, and they are used in industrial controls. So in this they are activated when an object makes physical contact with the actuator, and then they provide an electric or pneumatic signals. So in this a limit switch, it is actually a mechanical push button switch that is mounted in such a way that it is actuated when a mechanical part or lever arm gets to the end of its intended travel. So you can see some of the examples over here. This first example is of a limit switch mounted on a moving part of a bridge, and the second example you see here is a limit switch with a roller. You see here a roller lever operator, and this is installed on a gate on a canal lock, and it indicates the position of a gate to a control system. And on the right, this picture shows the limit switch, and these limit switches, they are used in a variety of applications and environments because of their ruggedness and ease of installation and reliability of operation. But there are two drawbacks of having the limit switch. The first is, being a mechanical device, they eventually wear out, and second is they require a certain amount of physical force to actuate. So you can see in this picture, without a force, this limit switch won't be able to work. So that is one of the drawback of limit switch. Now let's move on to the next sensor, which is the optical proximity sensor. So this optical proximity sensors, they sometimes also called interrupters, and they use a light source and a photo sensor that are mounted in such a way that the object to be detected cuts the light path. So for that, one such example is given over here. You see that this is a conveyor belt, and then these are the cans which are moving, and with the help of photo detector and a light source, the machine is able to detect like how many cans are passing through the conveyor belt. And further, if the digital circuits are attached, then you can actually see the number of counted cans on the computer. And here is another example which is given of a optical proximity sensor where it is detecting the read-only hole. You can see over here in a floppy disk, and that's how they are attached, and that's how it in a computer it reads the floppy disk. So in this optical proximity sensor, the light source, it may be modulated to give the beam a unique signature, so that the detector can actually distinguish between the beam and a stray light. So it is designed in such a way that it can distinguish between the stray light and the beam light. Now there are 4 types of photodetectors which are used, and these are commonly used detectors. First is the photoresistors, second is the photodiodes, third is the phototransistors, and fourth is the photovoltaic cells. And there is another type of optical proximity sensor, which is the slotted or optointerrupters. Now next we are going to see these different types of photodetectors. So let's first start with the photoresistor. So this is the circuit diagram of a photoresistor, and this is the graph which has shown between the light which is incident on the photoresistor and between the voltage, output voltage. So on the left you see this picture is the real picture of a photoresistor, and that's how they look like. And here you see on this on the top of the photoresistor, the light is actually incidented, and it is made up of a cadmium sulfide material, and which has the property that its resistance decreases when the light level is increased. And the next is the photodiode, and this is the circuit of the photodiode, and here it shows the relationship between the output voltage and the light, and you can see it is again linear, similar to the photoresistor. And this is the real picture of a photodiode. In this photodiode, it is a light sensitive diode, and a little window here allows light to fall directly on the PN junction, where it has the effect of increasing the reverse leakage current, and that reverse leakage current can further send to the next circuit attached to the photodiode. Now third is the phototransistor, and phototransistor, you can see here this is the circuit, and this is the real picture of a phototransistor, and you can see how the graph looks like for this particular transistor, phototransistor, which the graph here shows between the light and the output voltage, and you can see how it looks like. If we look this graph carefully, then we understand that when the voltage is high at that time, the light is very small, whereas as it increases, here we can see when the light is high, when the light increases, then at that time output voltage is going to be small. So in this phototransistor, when the light falls on the junction, then here you can see this is a junction, then the reverse current flows, which is proportional to the light. And photoresistors, they are used extensively to detect the light pulses, and they convert them into the digital electrical signals, and these are operated by light rather than any electrical signals. And then we have this photovoltaic cell, and this is the symbol of a photovoltaic cell, and this is attached to this op-amp circuit, and that's how the graph looks like between the output voltage and the light. And here you see the real picture of a photovoltaic cell. You see this small car, and on the top this is the photovoltaic cell. So in the photovoltaic cells, it creates the electric power from the light. As the light is incident on it, it will create the electrical power, and so if more the light it will have, then higher the voltage will be generated. So we saw all these 4 optical proximity sensors, and these are the symbols for these sensors, and corresponding to these are the real pictures of the sensors. Now let's see opto interrupter, which is a special type of optical proximity sensor. And here you see the proximity sensor, which has 4 leads, and each lead has a purpose. So first lead is a cathode lead, and second lead is the collector lead, and third lead is the anode lead, and fourth lead is for emitter. And here on the right you see the real picture of a opto interrupter sensor, and you can see it has 4 legs and each of them has a purpose. And in the center you see the circuit for a opto interrupters. So in this circuit you see a 5 volts is connected to the collector of this transistor, phototransistor, and the output is taken up from this collector side. And this is the emitter which is going into the ground, and then we have the LED attached to this resistor and further to the voltage source. So in this, to operate, power must be provided to the LED and the output signal taken from the opto transistors. So what will happen? The case 1 is when the slot is open and the light beam is strike on the transistor. Then in that case it will turn on the transistor which will ground the collector, and 0 volts will be produced in that case. And the second case is when the beam is interrupted. When the beam is interrupted, the transistor will be off. It will behave as a off transistor, and in that case the collector will pull the 5 volts from this resistor, and in that case you will get 5 volts, and that will be your cut state. So that's how the opto interrupter works. And these opto interrupters, they are widely used in optical switches, ATM machines, vending machines, office automation equipments, alarm system, etc. Now next is the Hall effect proximity sensors. Hall effect proximity sensor outputs a voltage when the magnetic field in which it finds itself increases. So this Hall effect proximity sensor, they were discovered by the scientist Edwin Hall, and he discovered a special type of conductor and semiconductors which provide a voltage in the presence of a magnetic field. So here on the circuit you see a Hall effect conductor or a semiconductor, and in which the current is flowing in one direction through this supply. You can see here this is the direction of the current, and the other terminals are basically indicates the output voltage, which is represented by VH, and VH is the Hall's voltage. And then here you have the magnet which is basically made closer, and it goes away from the Hall effect material so that the output voltage can be created. In this, the Hall effect principle, it says that when a conductor or a semiconductor with current flowing in one direction is introduced perpendicular to a magnetic field, then a voltage could be measured at a right angle to the current path, and the voltage which is measured is called your Hall effect voltage, and which is represented by this VH. And the formula for VH is this KIB by D, where K is the constant and it depends upon the material, and I is the current from an external source. So this is the external source, and from here the current is flowing, and B is the magnetic flux density created, and D is the thickness constant. The Hall effect proximity sensors, they are used for a variety of applications. So these sensing devices, they can be used to sense many physical parameters ranging from the direct measurements of a magnetic field to the detection of the ocean currents. One such example is they can be used in the brushless DC electric motors to detect the position of the permanent magnet, and they can also be used in sensing seat and safety belt positions for airbag control in the aircrafts. Now let's see this picture in which this is the simplified form of this circuit where it shows the conventional current, and this is the conductor, and this is the magnetic field, and as this magnetic field moves to and fro, depending upon that, the Hall's voltage will be created. Now next is the Hall effect interface circuit, and here the Hall effect voltage you see here, and this Hall effect voltage is compared using these two comparators, and these two comparators have the reference voltage. This one has 0.5 volts and this one has 0.25 volts reference voltage. So these reference voltages, they will be compared with the Hall effect voltages, and depending upon that the signal will be generated. So here when the Hall effect voltage is greater than 0.5 volts, then the top comparator, it will set the SR flip-flop, whereas if the Hall effect voltage is below the 0.25 volts, then the bottom op-amp, it will reset the flip-flop. So this is how you can use the Hall effect with the interface circuit, and this circuit particularly is an example of a threshold detector. And for this circuit to work, you need to make sure that the magnet in the Hall effect sensor, it comes near enough to sensor to make sure that this VH goes above 0.5 volts and far away for VH to drop below the 0.25 volts. So this is the end of the lecture. Thank you so much for watching.